Welcome to the webinar training series for the Equals Pre-Algebra and Pre-Geometry curriculum. In this webinar, participants will be provided with an overview of the Pre-Algebra and Pre-Geometry math curriculum. If you have any questions, you can contact the curriculum team by email at curriculum@ablenetinc.com. Please feel free to contact us for additional support or follow-up questions. Here's a list of things to remember as you begin to implement the curriculum. Establish a math center in your classroom. This is a place where all of your manipulatives, math tools, and focal point will be located. If possible, it should also be where your math lessons take place. Organize your materials and manipulatives so you know what you have and where to locate them. Explore the members-only content. There are many resources available in the members-only content, and the best way to become familiar with what is there is to explore. After you've organized your materials, view the pre-recorded assessment training so you can appropriately place your students in the curriculum. Finally, once you have assessed your students and/or determined a starting point within the pre-algebra and pre-geometry curriculum, view the pre-recorded lesson prep and lesson component training. This will provide you with a solid understanding of the lesson structure and supports. Equals Pre-Algebra and Pre-Geometry curriculum is a multi-sensory program that has been differentiated to support the individual needs of the students. This curriculum is aligned to state standards, alternate standards, as well as Common Core and Common Core essential elements. Building from the foundational skills of math, algebra is the study of patterns and relationships, while geometry is the study of shape, size, and relative position of figures, and the properties of space. Students learn about pre-algebra and pre-geometry skills in a way that builds and connects the two content areas to elevate the level of instruction and understanding. The goal is to build upon understanding of those early foundational skills of algebra and geometry to strengthen students' reasoning and problem-solving skills when working with these higher-level skills and concepts. What is important to remember when teaching pre-A and G is that we need to teach math seriously and thoughtfully. We need to focus on teaching math skills in context. What does this thing in my hand have to do with solving this problem? What does this mean for me in the context of the real world? And what does this mean within the system of numbers? We also need to focus on giving students the opportunity to connect what they are learning back to the larger picture of math. Helping students see what they learn in one lesson applies to the next lesson or a higher level skill is an important step when asking students to demonstrate understanding of their learning. These are tips from successful pre-A and G users. 1. Front-end organization is key. The idea is to know what you have and where you have it. 2. Resist the urge to print everything in the members-only content. You will not use it all right away, and there are many things available between these resources. 3. Take your time. This is new to you and your students. Once you get to know the structure, things will go much more smoothly. 4. Plan one day at a time, at least when you begin and until you feel you have a handle on the curriculum. 5. Remember your students. They typically process things more slowly and will appreciate the extra time to move through the curriculum slowly, at least at first. 6. It is typical for general education teachers to feel comfortable with the curriculum after 1 or 2 years. Equals pre-algebra and pre-geometry math content areas include not only algebra and geometry, but also numbers and operations, measurement, and data analysis and probability. These content areas overlap and connect in many ways. Students continue to build their skills in operations to support algebraic thinking and relationships between amounts, operations, and properties. Equals pre-algebra and pre-geometry lessons include the following math process areas: problem solving, representation, communication, reasoning and proof, as well as a variety of connections between these areas. Staying true to the same format as the Equals Math curriculum, we embedded these process areas into each of the lessons. You will find a minimum of 2 problem-solving opportunities in each lesson, multiple representations of numbers, written and verbal communication opportunities. Please keep in mind, when asking students to communicate, we are referring to communication in the broadest sense, supported to fit students' individual needs. Let's take a look at the algebraic thinking that is taught in the lessons of pre-algebra and pre-geometry. These are the algebra concepts taught within the lessons. We will briefly review these concepts to show the depth of each concept within the curriculum. understanding the relationship between inverse operations of addition and subtraction, and multiplication and division are beneficial for students as they learn more complex math concepts. Students learn about these inverse operations in real-world terms, doing and undoing. Undoing what one just did deepens understanding of the concept. Students add to do and subtract to undo, as well as subtract to do and add to undo. When students multiply to do and divide to undo, and the reverse, they begin to understand scale, a key concept in algebra and geometry. Many students are under the misconception that the equal sign signals an answer or a solution to a problem. In equals, the idea of the equal sign meaning equality on both sides of the sign was introduced. Because this is one of the most important concepts in algebra, it is taught in pre-algebra and pre-geometry multiple times. When students are working with part-whole relationships, we begin with understanding and building on students' number sense skills. We ask students to demonstrate an understanding of part-whole relationships by covering partial sums, then leading into fact families, and connecting it to multiplication and division concepts by showing the relationship between factors and products, as well as divisors and dividends. Part-whole relationships are extended then with fractions, understanding that the numerator represents the part and the denominator represents the whole. As well as understanding that in a circle graph, you are not comparing the amount as you would in a bar graph, but rather comparing the parts to the whole, which is why they are described as percentages. Iterating and partitioning is putting together and breaking apart equal parts. So when we put equal parts together and repeat by putting more equal parts together, we are iterating. When we break those equal parts up, we are partitioning. Input-output patterns begin in the curriculum with creating and describing geometric growing and shrinking patterns. Students see where a figure begins and describe how the pattern changes using a pattern core or change. This leads into describing the amount of figures in a pattern relating to the concept of functions and number patterns. Students are introduced to scalar relationships using tables. Here's an example of a table that shows that figure number 1 has 2 blocks, figure 2 has 4 blocks, figure 3 has 6 blocks, and figure 4 has 8 blocks. You can think of the relationship between the amounts as additive. Each figure has 2 more than the previous one, but now we want students to use the table to think about the relationship in a scalar view. As students start to see this, students can see 2 is half of 4, a third of 6, and a fourth of 8. They also use the table to recognize 4 is twice as many as 2, 6 is 3 times as many as 2, and 8 is 4 times as many as 2. Students have an opportunity to explore those relationships and also their understanding of using tables. This becomes a very important set of skills so they can apply what they know about scaling up and down, multiplicative properties, and the use of tables. Students begin to study ratio and proportion in the context of fractions. A ratio is defined as the relative size of 2 quantities, as you see in this fraction. And proportion is an equality relationship between 2 ratios, or in this case, equivalent fractions. We also introduce new sets of graphs from equals in pre-algebra and pre-geometry. Scatter plots, circle graphs, and box and whisker plots are taught in order to study graphs and measures of center. The intent is to allow students to utilize graphs to interpret information and data. Students learn about graphs by using accurate terminology, making comparisons, and predicting, as well as finding the range and the middle set of data. They will take what they know about graphs and start applying higher-level thinking to interpret more complicated or complex graphing. Students learn about positive integers, opposites, and zero. Students learn that integers are opposite whole numbers. Students see that positive numbers are opposite of negative numbers, and negative numbers are opposite of positive numbers. These skills culminate toward the end of the curriculum to have students apply their developing number sense, what they know about parts and whole, integers, and equality, to solve equations with unknowns. In addition to algebraic skills, students learn these basic geometry skills. Equality relationships, measuring and comparing 2D shapes, lines, and angles, naming and classifying types and properties of 2D shapes, lines, and angles, the spatial relationship of intersecting and non-intersecting lines, and graphs. The equality relationship comes into play in geometry when students measure and compare equal sides in a two-dimensional shape. They compare not only lines in two-dimensional shapes, but they begin to compare angles and learn all of these terms and figures in geometry. Students deepen their knowledge and application of shapes through naming and classifying. Lessons broaden the idea of what it means to classify by learning how to classify lines, angles, and shapes. Students identify types, properties, and use a table to organize the information. Spatial relationships are taught with intersecting and non-intersecting lines. Lessons provide opportunities to discuss how intersecting and non-intersecting lines look in space, such as on a map or within the student's environment. Students also learn about graphs from a geometry perspective. Students begin to learn about graphing linear equations. Moving out of the philosophy and content of Pre-A&G, let's look at what is included in the curriculum itself. The curricular kit, the manipulative kit, which is all of the hands-on based learning materials that will be used to support the lessons, and the members-only content, which contains data forms, number notes, games, and game materials, and materials lists for each section for preparation of lessons. The Pre-Algebra and Pre-Geometry curricular kit includes the following items: fraction circles for demonstration, a pack of assessment protocol sheets and the assessment flipbook to assess and place students in the curriculum, a set of work mats to help with problem solving, the teacher's guide, which contains all of the lessons from sections A through Q in order, the equals Pre-Algebra and Pre-Geometry overview guide, which is a book of resources to help support the teacher and provide general information about the curriculum and implementation process. 2 types of posters, theme posters with photographs and content posters, and 2 kinds of cards. The first set is vocabulary cards that are picture symbol supported, and numeral cards, 2 sets of 0 through 20. Let's take a closer look at the curricular kit items. As we look through the overview now, you may want to tab the sections within your book or write down the sections we discuss so that you can refer back to them as you begin teaching lessons. The overview manual is an implementation resource for you. You will find many supports in this book that will help you with the implementation process, such as assessment instructions, the scope and sequence, a glossary of terms, as well as a differentiation guide for your students. The contents pages, found in this overview manual, are a great way to see the entire curriculum from start to finish. The lessons are all listed in order and broken apart by sections. The sections in Pre-Algebra and Pre-Geometry begin with Section A and go through Section Q. The naming convention in Pre-Algebra and Pre-Geometry begins with the content standard. In this example, it is numbers and operations. Then, the section letter, A in this example, and finally, the lesson number, 1. The 6 lessons shown on the screen make up Section A. The scope and sequence gives teachers an idea of how far the program goes within each content area. In the example, looking at number sense or addition and subtraction properties, teachers will be able to see which sections these types of skills appear in, and what students would be expected to know in the context of that lesson. For teachers who want the broader view of the curriculum and to see how lessons unfold from sections A through Q, the contents pages will provide that in the order in which the lessons are presented. You will find the contents pages in the overview manual as well as the teacher's guide. Appendix A in the overview manual is for the assessment. Here you will find instructions on administering and scoring the assessment. For more information regarding the assessment, read through Appendix A or view the pre-recorded assessment webinar. Appendix B in the overview manual contains the glossary. Appendix C in the overview manual is where you will find the action dictionary. The action dictionary is a differentiation guide. The action dictionary contains a list of action words that students are asked to perform within the lessons. If a student does not perform an action in a typical way, the teacher could refer to the action dictionary for a springboard of ideas, so that all students can participate in a meaningful way. This slide shows an example of a page from the action dictionary. In this example, if we ask a student to move an object or move things into a group, and a student doesn't perform this action in a typical way, the teacher can turn to this page in the action dictionary and find a list of ideas to support their student when performing the action. You will find action words highlighted in a bold print within the lessons, and these are the words you will find in the action dictionary. Moving out of the overview manual, there are a set of work mats included in the curricular kit to assist students with problem solving and organizing manipulatives. These work mats can also be printed from the members-only content if you need additional copies for individual instruction or student practice. These posters can be printed in an 11-inch by 17-inch format like you see in the kit, or you can print smaller sizes including 8.5-inch by 11-inch. Work mats in pre-A&G, like and equals, are identified by the numbers found at the bottom. For example, the do and undo work mat seen on the left is work mat 5. Work mats will be identified by their number in your materials and within the lessons. If you are familiar with the Equals Math curriculum, you will notice some of the work mats have been carried over from that program. This is a very nice connection and support for students who are continuing on from the Equals program. It is important to note that there is a work mat guide available in the members-only content. This guide goes through many of the work mats and provides an example of how they are used within the lessons. As you come across each work mat within the lessons, remember to reference this guide to help you get a clearer idea of how it is used with the materials. You can locate the work mats by lesson or by work mat using the table of contents of this document. If the same work mat is used in a different lesson, both examples will be shown within the document. You can locate this document in Teacher Resources in your members-only content and open the work mat sample document. Let's review a few of the work mats now to give you an idea of how they are used with the manipulative kit materials. This work mat is for division. This method shows partitive division. Post-it notes could be placed to represent the divisor as the number of groups. Then manipulatives would be placed into each space until you run out. As you can see, there are 2 in each group. This method shows measurement division, where the divisor represents the amount in each group. Simply count the amount of the divisor in each square, then count the squares or groups to identify the solution. Another work mat used quite frequently is the 10-frame work mat. The 10-frame develops the student's visual representations of the amounts 1 through 10. Conversations surrounding this work mat also lend themselves to the relationship to 10. When learning about partial sums, students use work mat 25. And what they know about place value is expanded for addition. The equation 44 plus 25 is represented on the work mat using the grids to keep place value amounts in line as they expand. Now the students add the expanded forms to add the tens and the ones to identify the sum. Work mat 35 is used to connect multiplication to number patterns. Students learn about multiplication fact families by filling this work mat out. Students can use manipulatives, skip counting, or repeated addition to identify the product when multiplying 8 times 1 all the way through 8 times 9. This work mat is then applied when multiplying larger amounts on work mat 36. Students use the facts they identified on work mat 35 and apply those to multiplying 8 times 10. Students learn about distributing a large factor into smaller factors. In this case, students multiply 8 times 10 by breaking 10 into factors of 4 and 6. Now they can use work mat 35 to see that 8 times 4 is 32, and 8 times 6 is 48. Those products are added to identify 8 times 10 is 80. Again, please remember to use the work mat sample document to familiarize yourself with the use of each work mat, as they are so important to students' understanding and demonstrating their math knowledge. This was a brief review of how the work mats are used and taught within the curriculum. Remember to use the work mat sample document in the members-only content to become familiar with each work mat and the intent within the lessons. There are 2 kinds of posters in pre-algebra and pre-geometry: content posters and theme posters. These posters are also available in the members-only content. The intent is not to print them out, but rather to be used on an interactive whiteboard, a computer screen, or projected onto a screen from a computer. The theme posters support students in identifying the math they are learning within a real-world environment. The content posters support lesson content and are there to support students' understanding. Be sure to post the content posters within your classroom so that students can continue to reference them as needed throughout the sequence of applicable lessons. Here are examples of the vocabulary cards included in your kit. The vocabulary cards are all picture symbol supported and are labeled along the bottom of each card as vocabulary card. These vocabulary cards support students within the lessons and help students recognize important vocabulary through symbols and concrete connections made with students within the lessons. Here you can see the content cards included in your kit. There are 2 sets of numerals, 0 through 20. The content cards are labeled along the bottom as content cards. Content cards are used during problem solving and when representing amounts within equations and sets. It is expected that students in the pre-algebra and pre-geometry curriculum have a solid foundation of the 4 operations. If you are unsure of your students' understanding of the 4 operations, the assessment may be a helpful guide to check your students' understanding. The assessment flipbook and 10 protocol sheets are also found within your curricular kit box. There is a pre-recorded training available that covers how to administer the assessment efficiently and how to place your students within the curriculum. When you are ready for this part of the implementation process, please view this pre-recorded webinar to get started with the assessment. In your kit, you will find a USB drive that contains resources and materials for students and teachers. It includes worksheets, work mats, posters, student tools, pick symbols, assessment materials, and home letters in English and in Spanish. Throughout the curriculum, you will notice a reference to a CD. The USB drive has replaced the CD. If you need access to the members-only content, please contact customer service. Now we can move on to the manipulative kit. Here is a complete list of all the items that are included in the pre-algebra and pre-geometry manipulative kit. There are a variety of resources that are included so that students can communicate and understand math in their world. Take an opportunity to become familiar with the items in the manipulative kit. We will not cover every item in the kit, but there are a few to highlight. On the manipulative list, this is identified as a place value pocket chart. While this tool supports place value, it can also be used as a low-tech communication device. The pockets are deep enough to hold most of the manipulatives, as well as the vocabulary and content cards. The pocket chart supports students as they make thoughtful choices, explore, and place manipulatives in a designated space or field. The pocket chart is accessible for students through touch, pointing, eye gaze, and verbal communication. It helps build those opportunities and encourages students to talk about math, which isn't always an easy thing to do. You can reference the Action Dictionary for more ways the pocket chart can be used to support students' accessibility. This math tool is referred to as fraction stacks. Fraction stacks allow students to see and compare fractional relationships. Each post represents a whole, and the pieces are broken into different fractions for students to work with. It's a great way for students to explore fractions, and this tool is beneficial even for students who aren't familiar with fractional concepts. Sorting and placing fractional pieces lays the framework for what is to come in later chapters. There are 3 different math lines that are included in the manipulative kit. There is the math line to 31, which is a basic math line from 0 through 31. And then there are 2 integer math lines, a teacher integer math line, and a smaller student integer math line. The tabs on the math line are all the same size, which makes them accessible for students. The size of the tabs also accommodates many manipulatives that are included in the kit. The integer math line contains positive and negative numbers with a peg at 0. The protractor and circle protractors have been included as students work with angles and their measurements. On the protractor, there is an arm to assist with accurate measurements. An angle leg can also be fastened to the protractor to assist with accessibility. The circle protractor is a useful tool for providing a visual representation of angle measurements in relationship to a 360-degree circle. There is a set of pattern blocks included in the kit. This particular set of pattern blocks was specifically designed larger than the pattern blocks you typically find. The pieces of these pattern blocks have been created so that the smaller shapes can fit on top of the larger shapes to discuss equal shares and partitioning geometric shapes. There is also a printable set available in the members-only content as well. Included in the manipulative kit are demonstration fraction circles to show and demonstrate fractions to your students. There is another full set of fraction circles available in the members-only content within the Student Tools document. This set contains a larger and smaller set of fraction circles, both in color and black and white. There are times in the lessons when students will need multiple sets of fraction circles, such as when discussing mixed numbers or adding or subtracting fractions. There is a set of circle counters that are two-sided, red and yellow. The counters are mostly used to represent positive and negative amounts for adding and subtracting integers. They are also used in the last lesson when solving for a variable in an equation. The alternate spinner is an accessible spinner that is activated by pressing the large button on the front of the spinner or by using a switch plugged into the side. As you can see, the overlay is an alternative for rolling dice, but when you flip the inner and outer overlay templates, it reveals a blank overlay where teachers can attach cards or pick symbols with sticky tack for additional lessons. Teachers can also find an additional printable color overlay in the members-only content. The alternate spinner requires 2 C batteries. Visit the AbleNet website for additional ways to include the alternate spinner in the classroom throughout the day. The step-by-step communicator is a communication device that contains 2 minutes worth of recording space that teachers can use to record a single message or sequential messages. Students activate the message by pushing the button, and after the first recording plays, the next message is activated by pushing the button again until it cycles through all of the recorded messages. This is a great resource for rote counting, skip counting, having a conversation, completing activities with multiple step directions. Really, the opportunities are unlimited. Again, I encourage you to visit our AbleNet website for more ways to use the communicator during the day. The step-by-step requires one 9-volt battery. Concrete representations and hands-on opportunities are critical in order for students to continue to understand and develop a deeper understanding of math. The manipulatives on this slide provide countless opportunities for students to work with hands-on tools while problem-solving. Items such as the pocket chart, step-by-step communicators, math lines, and the alternate spinner allow students to talk about math, be active learners of math, and show what they know. Manipulatives are used with consistency in mind, so as students progress through the lessons and learn new skills, they can apply what they already know about previously learned skills, manipulatives, or tools to their new learning. Many of the manipulatives seen on this slide are used in a variety of action words within the action dictionary. The action words are cross-referenced so that students who once used the math line to count can apply what they know about counting on the math line to adding and even multiplying as their skills develop. As a reminder, keep the action dictionary present while you teach so that you have a way to support your students during the lessons. The last piece of the curriculum includes access to the members-only content. In the members-only content, you'll find a materials list for each section. This is a new way to gather and organize materials to support teachers when prepping for lessons. New games to support some of the pre-algebra and pre-geometry lessons. Printable number notes pages created for levels 1, 2, and 3. These can be used as math journal pages for your students. You will also find money cards, a digital version of the action dictionary, and to support that school-to-home connection, there are home letters which are now available in both English and Spanish. As we conclude this webinar, I would like to thank you for your time today. The Equals Pre-Algebra and Pre-Geometry curriculum provides consistency and support as students are introduced to new math skills. If you have any questions or would like to request a live training for the Equals Pre-Algebra and Pre-Geometry math curriculum, please contact a curriculum team representative at curriculum@ablenetinc.com. We look forward to hearing from you.